All right, previously we talked about how to write equations using polar coordinates, and those were pretty easy because any x you saw, you could simply substitute an r cosine of theta in, and any y you saw, you simply substitute an r sine of theta in. Now, converting to rectangular coordinates is a little more tricky, but it's not too bad still. So the big thing we want to do is see if we can easily convert the equation so that we can use one of these four equations. It could be any of these four. So for instance, I personally see that there is a cosine of theta. This top equation also has a cosine of theta, but notice how there is also an r with that r cosine of theta. So what I'm going to do is I'm going to go ahead and multiply this side by r, which naturally means I need to multiply the other side by r. And we'll get 2r squared equals r cosine of theta. Now notice, now we have the full r cosine of theta. That's equivalent to x. That's actually something we want since we're trying to convert to rectangular coordinates. We want everything to be in terms of x and y. We don't want an r, we don't want a theta. Okay, so we can do an easy conversion right here. So let's look at that r squared. Is there an easy conversion for that one as well? The answer is yes, because of this third equation. R squared is equivalent to x squared plus y squared. So we're going to go ahead and do substitutions. So we have 2 times x squared plus y squared. That's going to equal x. And I'll go ahead and distribute that 2 in. 2y squared, there we go. That equals x. And now that everything's in terms of x and y, we've converted the equation using rectangular coordinates. So let's go ahead and do one more, just so we can see that process again. So once again, we're going to use any of these four equations. We want to convert r equals 7 using these. And so you want to use one of those tricks again, either multiplying by something or changing the equation somehow, or changing the way the equation looks somehow, so that we end up using one of these equations. So for instance, I could go ahead and try, since this is r cosine of theta, I could try multiplying this side by cosine of theta, and then this by cosine of theta. So we get r cosine of theta equals 7 cosine of theta. However, the issue is, although this now has an easy conversion to x, this side has just a plain old cosine of theta. So it's not going to convert easily. If I multiply by r, we'll get an r squared on the side, and it's just going to get really complicated and messy. So that probably wasn't a good option. In fact, we'll have the same issue if we multiply both sides by sine of theta. So chances are those two aren't going to help us. Now this one might, though. We have just an r, we don't have an r squared, so maybe we can multiply by r. However, if we do that, if we look at this, r squared we can easily convert or substitute x squared plus y squared in for that, but we then have just r. And we could do some sort of conversion, but there's another way we could actually work with this. So instead of multiplying by something, I can go ahead and just square both sides. So that I end up with r squared equals 49. Now you'll notice now we have a really easy conversion. We just need to go ahead and substitute x squared plus y squared in for this in for the r squared. And then we'll have our final answer, because everything will be in terms of x and y. And there you have it.